Hi, welcome to my second tutorial on graphs. In the previous video, we discussed how to plot a graph of a linear equation. So in this lesson, I'm going to show you how to draw a graph of a quadratic equation and how to use that graph to find the different unknown values which we need to find out when we are doing any kind of a mathematical problem. So let's check it out. These were the questions that I showed in my previous video. We are going to do the second question now, which was to construct a graph of this quadratic equation. So first of all, we need to complete this table which is given in the question. So the x values are from -3 to +3, and then we are going to calculate the unknown values of y, and then we are going to proceed towards the plotting the graph of this particular equation. This was the previous graph that we did in the linear equation problem. So I'm going to use the same workbook here, but I'm going to use a separate sheet for a separate question. Let's zoom it a bit. Okay. Now, just as before, when we did the question of a linear equation, in the case of a quadratic equation, we again need to first calculate the table of values. Now some of the values are given here, and the first step of this question is to copy and complete the table. So what we can see here is that the values of x start from -3 till +3. So the range of values of x is known. So the corresponding values of y need to be calculated. 4 of these values are given, but the 3 values are not shown here. So for that, we need to first construct the table of values. Just like before, I'm going to write x and y in the two columns, and we are going to start the values of x from -3 till +3. So I'm going to type all these values of x myself. Now, as before, in the cell of the y values, we need to write the formula for the equation rather than writing the values ourselves, because we need to use Microsoft Excel to calculate the values of y. So as before, in order to enter a formula, we need to place an equal to sign first, and the equation was 6 plus x minus 2x squared. So the 6 is a constant. We're going to write 6 as it is. Then we are going to add x into it, but not simply x. We need to select the cell which contains the value of x like we did before, and then we are going to subtract 2x squared from it. So 2 times x squared means that we need to write 2, and for multiplication we need to place a static sign, and for x we are again going to click this cell, but this time for x squared we need to write it 2 times. So this makes it 6 plus x minus 2x squared. Now we're going to press enter. So we get the value of y as -15, and if we check the table which is given in the question, the y value is already -15. So that means we have entered the formula correctly. Now for the next values, just like in the previous video, I'm going to take this mouse to the bottom right hand of the cell, and as this white plus sign changes into a black sign, then I'm going to place enter left click and drag the mouse downwards so that all the values are calculated with respect to their values, corresponding values of x. So if we check the formula bar here, for -15, the cell used the value of B5, which was the corresponding value of x. But in the case of the second y value, we can see that the formula has automatically changed to B6. So Excel has intelligently picked up the correct value, the following value of x, which was in the cell in the immediate left hand corner. So in the following cells, we can see that in all of them the values have been correctly updated by Microsoft Excel. So this is how we can easily complete the table, and as before, we can format this table as per our requirements. We can place a border here as we like, or if we even don't want to, it's okay. So now we place the border here, and I'm going to just bold these letters and align them in the center. So this is how I'm going to complete the table of values. So now the unknown values which we needed were against -2, 0, and 2. So the three values are -4, 6, and 0 against 2. So we have calculated the unknown values very easily using the formula calculator of Microsoft Excel. So the next step now is to construct the actual chart or actual graph of this equation. So for this, we are going to refer to the question again. Here the question says that using a scale of 2 cm to represent 1 unit on x-axis and 1 cm to represent 1 unit on y-axis, draw the graph of this equation for x minus e to plus 3. So this is how we need to construct the graph, keeping the scale on both of the axes in mind. For graph, you're going to go to the insert option, and as before, we need to select the scatter chart for the coordinate graph. Again, I'm going to, just like in the linear equation graph, I'm going to select the chart which only plots the points, and later on we can adjust the axis and the scales. So this is a chart area. I'm going to right click and select this option, select data. Now in the select data, we need to enter a data series here. Series can be named as the equation of the line, like y is equal to 6 plus x minus 2x square minus 2 times, I'm going to write x into x. So for the x values, I'm going to just select the respective cells using my mouse, and here it has automatically filled the required values for the selection of these cells. And for the y values, we're going to first remove this, and then we can again select the column which contains the value of the y coordinates. Now here the plots have been done, and I'm going to press OK, and the series has been successfully added. So this is looking as a curve, not a straight line, because the graph of a quadratic equation looks like a parabolic curve which has either a maximum or minimum point. So I'm going to select the quick layout option to adjust this graph and to show the grid lines. We can also do that manually, but using quick layout is an easy option. Now we're going to just resize this chart area a bit according to just like we want to. Now this graph is a tentative graph right now. What we need to do now is to join all these points using a trend line here, just like we did in the case of linear graph. So as before, we are going to select any of the points, and we can see all the points are now selected. We're going to right click, and we are going to select this option, add trend line. So add trend line, we can see the different trend line options. We selected the linear one last time, but in the case of quadratic equation, we know that the quadratic equation is not of a linear kind, and also it is clearly seen that the straight line is not matching these points. So we are going to select, for quadratic equation, we're going to select the polynomial of order 2 here. Order 2 means quadratic equation, order 3 means cubic equation, but order 2 fits here because this is a quadratic equation. So as again we can see that the lines have now been joined, and we can adjust the trend line by converting into a continuous line rather than a dotted line. We can change the color to black, and we can also reduce the thickness to 0.75. So this looks better now. Now what we need to make sure is that we follow the scale as mentioned in the question. So we need to use 2 centimeter to represent 1 unit on the x-axis. Now considering this one major unit as 1 centimeter, right now this is not according to the scale. Also, if you can check the y-axis, then 1 centimeter represents 5 units, though we need to enter 1 centimeter to represent 1 unit option. So this is not according to the requirements of the question at the moment. First, just we need to extend this line forecast, because this curve is just between the data points here, but we should extend it a bit. But even if we don't want to, we can leave it, because in this question they have specifically asked -3 to +3. So we should restrict our graph here in this question, although we can extend it using the forward and backward options. So now what we need to make sure is the scale of the axis. For this, we need to select the axis option here, and we can see that now this option bar has changed to format axis. We can also right click the axis and then select format axis. This will do the same. Now here we have this option, minimum and maximum bounds, and the units option here. Now the major unit is at the moment 1. What we need is, we wanted on x-axis that 2 boxes should show 1 unit. So that means 1 unit should show 0.5 units. So I'm going to change this option to 0.5. And now we can see that 2 centimeters is 1 unit on the x-axis. And the minor units we can change if we want to. We can use 0.1, or if we want to show 10 boxes inside, we can select the 0.05 option here. This will convert this scale into 10 minor grids. So here the minimum and maximum value now is written as -3.5 to 3.5. We can convert it from -4 till +4. Now the axes are from -4 till +4. Now in the case of y-axis, we can select again. Now one box should represent 1 unit here. So the major unit should be 1 centimeter to 1 unit. So we'll select 1 here. And in the minor option, if we want 10 boxes, so 1 divided by 10 means 0.1. So each box now has 10 smaller units. We can now shrink this graph to make it a square shaped. So this is how we can now adjust the scale. The scale is now perfectly adjusted according to the question. For the labels, we can adjust the labels accordingly if we don't like this format. So label position is next to the axis, and the numbers has a general category. This okay. And tick marks should be cross, and the color should be also adjusted. You can convert it into a black color. So this can be done here, and in the axis options, axis value, minimum axis value, maximum axis value can be adjusted here. So these are the basic settings. Now we can change the axis title also. We can write it as y-axis, and here we can write x-axis similarly. Now we can select the x-axis, and again we can format this accordingly. Tick marks should be cross, and the axis option it is taking from -17. It's okay, we can adjust it as we like, but I think it's fine. And then I'm going to change the color of this axis as well to the black one, and I'm going to place the arrows here. Here we can see that the arrows are now placed, and similarly the arrow at the top should be inserted as well. So now the top arrow is done, and similarly in the case of x-axis we should place the two arrows again. So we have gotten different options. We have got to see the different options here. There are many other things that we can adjust, and we can adjust the color of the values as well if we like to in the text options. If we change it to black, you can see that the labels are now colored black instead of gray. So we can zoom it again as we like. Okay, now here we can see that we can't see the grid lines very clearly. So what we should do is, we should not, rather than zooming it, we should enlarge it. I'm going to take it over here, and now I'm going to enlarge this graph, and then I'm going to, let's shrink it some more, then we can. Now here we can see that we can, if we zoom it again, now the grid lines are slightly visible. We can enlarge it a bit more if we want to, like let's shift it again to 100%, and we can enlarge it a bit here. I think now it's sufficient because we can clearly see the boxes now, the minor boxes as well. So now we can simply calculate the next values. The first part is to calculate the value of y when x is equal to 0.4. Now in our axis settings, we selected in the x-axis that one minor unit should be equal to 0.05. So that means that 2 units will make 0.1. If we need 0.4, then we'll have to move 8 units, like 0.1, 2, 3, and 4. So we'll have to check this particular division, 0.4. Now I'm going to zoom a little bit more so that we can locate the point very clearly. Okay, here. Now the second last point before 0.5 is 0.4. So we're going to move here, and we can see that if we further zoom it a little bit more, then this becomes 6.1. At 0.4, the value of y is 6.1. So this shows that the value of y when x is 0.4 is y is equal to 6.1. So this is how we have calculated the value of y using the accurately drawn graph. In the second part here, now we need to find the values of x when y is equal to -6. Now it is mentioned values rather than a single value. That means that we will get two values. So if we have y is equal to -6, then we'll have to shrink the graph again and go into negative y-axis. There we have -6. So what we need to do is that we need to basically draw another straight line. Now an easy way to do that, what we could also do in the previous part, was that we can draw a line here which is y is equal to -6 to make our calculations much easier. For that we can select another table, or just like if I select x and y again. So for, let's say, I'm going to select -3, then minus 2. Again, I'm going to draw the graph from 0 to 3. But now I'm going to fix the values of y to minus 6. Or if we are not entering a formula, then we can simply write minus 6. We don't need to write the formula sign. And we can simply just drag this same value down. So y is equal to minus 6 means every point on the line has a y coordinate of minus 6. So I'm going to select this graph again. I'll zoom it out again. And then I'm going to right click this chart area. I'm going to go into select data again. Now this was the curve, the series which was previously added, this table. I'm going to add a new table now. The series name will be just simply y is equal to minus 6, and the x values are as before selected using the mouse, and the y values just like before again. So when I'm going to press OK now, I'm going to get a new line, a new data points, which I'm going to select and add trend line. But this time I'm going to select a linear line because that's a straight line equation. And I'm going to again make it a permanent line and a little bit thinner so that it's easily visible. Now this line basically has the equation y is equal to minus 6. So the easier way of doing it is that we are going to match the points which are the basically intersection points, the points which are common between the curve and this line y is equal to minus 6. So I'm going to close this box, and now we're going to check that at which of the 2 points these graphs have common points. So one of the point is this point and the second one is this point. We need to find the values of x for these 2 intersection points so that we can locate it. Now checking it more closely, so that's 2.5, that means 2.6 and 2.7, 4 minor boxes after 2.5, so that makes it 2.6, 2.7 plus 2.7, and in the other side we have minus 2 here, so minus 2.2 and minus 2.1 and minus 2.2 is this one. So that's how the 2 values of x are minus 2.2 and 2.7. So I'm going to write the answers here. Minus 2.2, or sorry, I'm going to do it again, and 2.7. So these are the 2 values of x. That's how we can calculate the values of x. And the next part is the equation for the line of symmetry for the curve. Line of symmetry is basically a line which actually divides the curve into 2 equal parts, or which passes exactly through the center of the curve. So for that we need to check what is the turning point of the curve. For example, if I'm going to zoom it out, we can clearly see one thing, that the curve will be symmetrical if we draw a vertical line through this maximum point. If we draw the line through the maximum point, then this line will divide the curve into 2 equal parts. If we draw the line from a point other than the maximum minimum point, for example, if we draw a line through this point, then the 2 parts on the right and left side of the curve will not be same. So the curve divides exactly into 2 parts through this turning point or maximum or minimum point. In this curve we have a maximum point. So what we're going to do is we are going to first check the x coordinate of the maximum point. The x coordinate of the maximum point is 5 minor units away from 0. So that means that's 0 0.1, 0 0.2 and 0.25. That's exactly in the middle. So the value of the x coordinate of this maximum point or the turning point is 0.25. So as we now know the x coordinate of the maximum point, we can simply write the equation of a vertical line which passes through the x coordinate of 0.25 as x is equal to (0.25). So this will be the equation of the curve for which here I'm going to capitalize now. So this is the equation of a line which is vertical or parallel to the y-axis, which has an equation of the form x is equal to something. So as we know the x coordinate of that point, so now we can write the equation as x equal to 0.25. So this is how we determined the value of the equation of the line of symmetry. Now for the last part, the greatest value of y, we can check the graph again at what y coordinate is that curve passing exactly. There are two ways to find that value of y. Either we can use the equation or we can check from the graph directly. So if the graph is not very clearly visible, then we can use the equation as well, as we know the x coordinate now. So this point is slightly greater than x 6.1. So if we need to check the confirmed value, we need to put the value of x equal to 0.25 into the equation. How do we do that? We just put this value of 0.25 here, or we can use our actual table which we constructed before. We can simply write another value here, 0.25, and here we get the value of y as 6.125. So that's how we can determine the exact or accurate value using the equation rather than the graph, or if we can clearly see the graph, then we can use it as well. So that's how the value of y, the greatest value of y, will be 6.125. So that's how we can solve this kind of a questions in which we need to draw a graph of a quadratic equation using Microsoft Excel and perform some calculations or determine the unknown values by using this graph again. So I hope you like this video and have learned a lot how to solve a mathematical problem like that. So for more videos and more updates, please subscribe to our channel and keep watching our new videos. Thank you very much and have a nice day.